So up until now, we have talked about Java's exception classes that it gives you to deal with erroneous situations that Java could anticipate. And it's a really powerful hierarchy. They give you a lot of exceptions that cover a lot of bad things that might happen, right, with user input or with problems in your code. They give you a ton of exceptions to cover a lot of instances. But the other thing that makes Java exception handling so powerful is that it allows you to create your own exceptions to handle situations that might come up. So everything up until now has been using Java's exceptions, but the last thing we're going to talk about is allowing you to create your own exceptions to explain erroneous situations that might come up. Okay, so you can create these kind of exceptions, and you have to think about whether this makes sense. So sometimes it makes sense to just use a simple if else test to discover if a situation has happened and if you want to handle it. But sometimes you might decide that you actually want to create your own exception class and use exception handling to handle that situation. This is a design decision. If you're working with a group or with a company, they might have a standard approach of when exception handling should be used and when just regular conditionals should be used. If you're just writing your own code, you kind of should come up with your own guidelines of when you think conditionals should be used and when exception handling should be used. So in order to define your own exceptions, you basically just create a class, and that class becomes a child of one of the exception classes. Okay, so if you were just having a general unchecked exception, you could extend exception. If you wanted to create your own exception class that was related to input and output, you might extend IO exception, for example. Okay. Now, when you create your own exceptions, remember up until now, Java has determined when an exception situation happened, and it created and threw an exception object. If you're defining a new context that might describe an exception, you're the one who has to throw it when that context happens. So with Java created exceptions, Java throws it. But if you define your own exception, you are responsible for throwing that exception. Okay? And you do that using a throw statement. So a throw statement is just the keyword throw followed by the object, and that object is going to be a new object of the exception class that you create. Typically, that throw statement will be inside an if statement that says, hey, if some condition happens, throw this new exception that I just defined. Now, this is where I mentioned earlier, be careful about the distinction between throw, singular, which is used to throw an object of an exception class that you create, and throws, plural, which is used inside a method header for propagating checked exceptions. Okay, so be careful about throw versus throws. Okay, again, this is best seen through an example. So let's create our own exception class, and we're going to go back to our shipping code example that we worked on previously. And we want to say, okay, we handled a bunch of situations here, right? The user put in a code that was too short. They put in a code that was non-numeric. But what happens if we run this program and they put in a code that is a character, right? So 94117, but what if they put in like a T? Well, the program's going to run just fine, right? But nothing's going to indicate that it says that it was a valid code and that wasn't a valid code, right? T is not one of my shipping codes, so I don't know what to do with a T, right? So I might decide I want to use exception handling to deal with this. Now, I could, of course, also put another else here, right? I could say if my ship speed string was an S, it's standard. If it's E, it was expedited. I could say else, so if it's anything else, print an error message. But right now, I have this nice block of code that just deals with all my normal execution flow, right? This is all like if things go right. There's no other code in here that indicates what should happen if something goes wrong. I have that all in my catch statements. So it's kind of nice if I don't have to have an else in here, if I can just, that prints out an error message to the user. But if instead I can gather all of that kind of execution flow in one place. So I'm going to decide I'm going to use exception handling to deal with this instead of just using an else with an error message. So what I want to say is, okay, otherwise, so if it's not an if, that last character is there, right? Because if we get down to this point in the code, we know that I was able to get that character correctly. But if it's not an S or it's not an E, that means it's something else. So this is going to be my my own exception case, right? So it's an improper code. So I want to do something here. And what I want to do is I want an exception to be thrown. But I can't rely on Java to throw that exception because Java doesn't know, incorrect shipping code exception. That doesn't make any sense to Java. So I need to create that class myself. So what I'm going to do is I'm going to create a class. I'm going to call it improper or invalid shipping code exception. Now, most exception classes will have really long names like this because they're descriptive. So exception classes will typically look like this. And they're also usually really, really short. They're really simple classes. They have kind of two main components. The one most important component is that it extends the exception class. So this is an exception. An invalid shipping code exception is an exception. And the beauty of saying that is that I now get to take everything defined for Java exceptions and apply it here. That means I can throw them, I can catch them, I can propagate them. All of those things I can do with my Java defined exceptions, I can now do with my own exception just by adding that keyword extends exception. I get all of the benefit of the Java defined exceptions. That's pretty cool, and it's pretty powerful that in just this simple little class, which right now has no other code in it, I've now created my own exception that does everything that the Java exceptions do. So that's the most important part to add to my exception class. Pretty much all the other thing I'm going to add is a constructor so that I can create these things. And my constructor is most likely going to look like one of two things. It's either not going to take any parameters, at which point I'm just going to call the parent constructor, which would be the exception constructor, and I'm going to maybe send in a string describing the exception. If I send in a string, this is the message now associated with my exception. So previously when I printed out that exception, like ex.getMessage or problem.getMessage, this would be the message that prints. Okay, so this is pretty typical. This is what my exception class will look like. That's pretty much it. It's pretty straightforward to create my own exception. And again, the reason that it's so straightforward is I get to use inheritance. I get all the good stuff from Java created exceptions just by saying that my class extends exception. The other kind of typical constructor you'll see in an exception class would be to take in some information into the constructor, like a message, so that when the user of this class creates an exception, they can define their own message, and then I would just pass that message along to the parent constructor. So these are kind of your two options for what your constructor might look like. You probably wouldn't have both. You'd probably either allow the user to create the message or you just have a default message. You might have both, but most likely you'd have one or the other. So now I have this exception, and now I can use it. So now I can say, okay, if this character is an S, it's standard shipping. If the character is an E, it's expedited shipping. If it's neither of those, I have this new exception situation. So I want to throw a new object of type invalid shipping code exception. Now, I'm getting an error message, which I'll talk about in a minute, but this is how I generate my own exception. So if an exception happened here, a Java-defined exception where I'm trying to parse an integer, the string that doesn't contain a number, Java throws my exception. If an exception happens here, where I'm trying to get a substring that doesn't exist, Java throws my exception. But here, I'm defining what the exception is, and so I need to be the one to explicitly throw it. Okay? So if I'm using a Java-defined unchecked exception, Java will be the one to throw it. If I'm using my own exception, I have to be the one to throw it. And by throwing that exception, it essentially becomes a checked exception, meaning that once I throw an exception, I can't ignore it. I have to do one of those two other things. I have to either catch it or I have to declare that this method propagates it and throws it somewhere else. Okay, so one option would be I can say that the main method throws this type of exception. Now, that'd be kind of silly, right? Because why would I create my own exception, throw it, and then just let it crash my program anyways? I'm not going to do that. But from a compiling standpoint, that would be one option, just like with a checked exception. Or what I'm most likely going to always do is catch it. So I'm just going to add now another catch clause. And if I get into that catch statement, I'm just going to print out invalid shipping speed code. Try again. I'm going to increment my number of invalid codes that the user has entered, and that's it. Now my compiler error goes away. So I throw my exception that describes my new instance, my new error situation, and then I catch it and I handle it. And the reason, again, that I can put this class I just wrote inside a catch statement is because it extends exception. So it is an exception. And catch statements can be used with any exception, any type of exception, including the one I just made up. So now when I run my program, I can enter a good code, and I can enter a bad code, and it gives me the appropriate invalid shipping speed code, and it increments the invalid count. Okay, so it's pretty straightforward to create your own exceptions from a programming standpoint. It's really easy to write these classes. You want to put some thought into what you want this class to represent. So what situation is represented by this exception class? That's where kind of the work comes in, is thinking through logically when this should happen. And then once you create that exception class, thinking about where in your code it should be thrown. And then once you throw it, you also have to handle it.